So, all right. In past videos, we mentioned something about lighting, we mentioned something about render, but we've not really dived deep into it. So, in this short screen record or short video, I'll explain the difference or the value or use case or importance of lighting and camera, right? So, now looking at this is lighting and render, yeah. So, looking at this, we have the camera. So, like I said in one of those videos, that in the camera video, that there is nothing that can leave Blender, like render an output, something you can post, something you can post on your socials, on your YouTube without a camera. So the whatever you model, you create, you invent in Blender or in any 3D application, wh- what people see is what you want to you reveal to them through the eyes of the camera, through the eyes of the camera. So now we have your camera, but now this is when I move to this area here, preview, you notice that this is blown out. The last one here, which is the preview, render preview, everything is black. And the reason why it is black is because there is no light on the scene. So the camera is set, but there's no light in the scene. And the absence of light will give you darkness. Everything just be dark, right? So to bring in a light, you just shift A, you have light. So we have four types of light in Blender. We have the point light, the sunlight, the spotlight, and the area light. Now, this point light is like the light of a bulb, physically, all those room bulb, all those, yeah, that is this point light. The sunlight is like the sun. The beauty of the sunlight is that the sunlight light everywhere. Let me just show you how it does. So when I click on the sunlight, everything is bright with the sunlight. Everything is bright with the sunlight. The only thing about the sunlight is that it only the direction matters, but the light size, the intensity of the light touches everywhere like normal sunlight. So the sunlight affects everywhere uniformly. We also call it directional light. It's lightened everywhere, just that the direction is what the most important with the sunlight is the direction. Let me delete this. The next one is the point light. The point light is, like I said, like a bulb. It's like a bulb. So the effect is just a spot. So light is coming out from a point in space. Like your bulb now, when you fix it, light the light source is from that one spot. So let me delete this. The next one is the spotlight. Now the spotlight, when you go to areas like the like opera now, you notice that there's a light is like the light in the room is focused on the singer or on the musician or whatever. So it's giving you this roundish glow. So that's the advantage of a spotlight. Now, in spotlight, it keeps one thing on the spot, just like the name spotlight. So it focuses on one. You can make it focus on one area. To give you that seclusion, and every other thing around outside that glow, outside that cone-like structure is black or is excluded from light. So it's like when you go to the cinema, everywhere is dark except from the screen. And that's an example. So if you want to depict the cinema lighting, what you use is this last one called the area light. I use this a lot, by the way. The area light. So the area light is a light that has either a structural form, either a rectangular or a circular structure. So you can use this like the light from a TV, like the light from your smartphone, like the light from a laptop, like the light from not a projector. A projector's light is likened to, yeah, from a light source projecting, yeah. Is that more like a spotlight or also mixed with, yeah. A projector's light is a spotlight. A projector's light is a spotlight. So the spotlight. So that this area light is a light that is structural. think the best illustration of this spotlight is the current type of lighting that you see in most places where when you look at the roof, you have this box-like lighting. So those are the area light. I use them a lot, but basically. So you can use them to do many things. Even you can use them to do spot. I can make them act like spotlight, make them act like um point light, depending on what you want to achieve. Yeah. So the more interesting your lighting is, the more beautiful people appreciate it. So and every of those lights, you can see their property here. You can change the color of the light. You can change the power or the intensity of the light. Every of the light has this can affect them. You can change the size. But like I said, apart from the sunlight, every other light, sunlight and the point light, yeah, sunlight and the point light, I believe, every type of light has a size. The sunlight, the size doesn't really affect anything, just the direction. The spotlight and the area light, those two, their sizes matter and their direction also matters. But the point light, the location, not the size or the direction, the location matters, like a point in space. All right. And also, every light casts shadow. So depending on how you want your light to be felt, how you want it to be seen, how you want it to be appreciated. Sometimes you may not want shadow to appear. Sometimes you may want shadow to appear. Either way, so this is just like a beginner into lighting and render and materials. We'll still do a separate video showing us more advanced way to approach it. More advanced way to approach it. All right. So let's just from this the lighting. Let's assume. Let me say something more interesting. Let's do a spotlight, an area light. Yeah, let's use an area light. Move it up and then maybe turn it up. Yep, that is face this side. Move it backwards a bit more. Yeah, then make increase the size and then let me increase the intensity of the light. Yep. Then let me move this guy forward. Yeah, so you can have that shadow underneath. Yeah, let's give it that sweet shadow. Sweet shadow. Alright. So now this guy is too sharp. Let's add some bevel to it, as we mentioned in one of our classes. Bevel. Yeah, don't get me wrong. I'm using this interestingly looking basic shape so that you understand how this can really affect. Yep. So you notice that you can see that the light is stronger here, but less strong here. You can see this dark area, that is shadowy area, that is contact, and then I have the shadow on the floor also. So anyway, there is a contact, there's an obstruction of light. You find that you find this kind of dark area. So those are obstructing the light from penetrating. So so let's give it a texture. Now this is a round one. To give it a texture or better still material. The first level of texturing, the first level is material. The kind of material that your object should bear. So if it's a wood, you need a wood-like material. If it's um glass, you need something glass-like and also a little bit transparent. So for this one, let's just click on this one, go to the material with this area here, this one. You can see material, click on it and add, let's give it this color, let's use this also, let's give this color and this, let's give it another color. Let's use something like this, okay, something like this, yeah. So now let's give this one zero roughness. You can see zero roughness. Let's increase the roughness of this one. Let's drop the alpha. Now what I just did now is me messing with the materials. Now look at this one. Initially initially it was 0.5, meaning that it is not too glossy, it is not too opaque or shiny. So it's when this part here roughness affects the glossiness of the material. So 0% or the 0% roughness, it means that it is very glossy. We are like a wet surface. But like for 100% roughness is like a wooden surface, a wooden surface. It is quite um it's not shining at all. Not shining at all. So most of your cloth materials like the foam and the like, they are all 0%, they're all 1% or 100% 100% rough, 100% rough. But let's move this one down here. We have this, and for this, I reduce the alpha to make it a little bit transparent. So let's assume I let this alpha at 100, but then I increase the metallic. So the more it is 0 to 1, 0 means 0%, 1 means 100%. So the more metallic I want, so this looks like more like an iron by let's change it to something whitish, give like a silvery structure. So now this is 100% metallic. So depending on what you are going for, all these material sets will affect your textures. So for human beings now, we are not metallic. At the same time, we are not glossy. So a combination of how our skin tone and how diffuse our body is, how light pass through the skin of a human being is will will the combination of all this will give us a perfect human skin. For let's say for water is largely 0% rough because it reflects light and it's but then the amount of light that can pass through a glass depends on depends on how transparent the glass is. So the how transparent. So in the real world, glass are not 100% transparent. Some areas of the glass will be rough, some areas will be shining. So when we get to the advanced level of texturing, I will explain how to create some interesting texture that's not just plain plain white, plain black, plain blah blah blah. So in 3D, when you hear zero, zero means 100% black, and one means 100%. Zero means 100% white, and one means 100% black. So the black area is like a no-go. So if I'm adding, let's assume for instance, I want to make my material raw. So 0% of that material is, I mean, zero roughness is white. 100% of that material that 100% rough is black. So meaning that black resists and white permits. White resists white, black white permits. When we get there, we'll explore that. Yeah. So and finally, to render this simple project, up here you'll find something called render. Now in Blender we have three basic um render engines. We call them render engines. But if this one Workbench, we don't really use it because it's the default render of the viewport. We have Eevee and we have Cycles. So Eevee is the much more accurate, we call them physical based rendering, PBR, physically based rendering. It is much more accurate to how real life operates. And the Eevee, this one is faster, but is not as accurate as Eevee as Cycles. So Eevee is much more fast. So Eevee is like a game engine. Whatever you are doing, the response is very fast. The response is very interesting. But for Cycles is much more detailed and much more intentional. So most times, because of the strength of my PC, I use Cycles. I use Cycles almost all the time. I use Cycles almost all the time. Yeah. So for my Cycles, this I can change it from here. So there or up here, you can find those rendering settings. So this last one is called the viewport shading. This one is similar to what you will find when you finally export it, what you are seeing currently. Now this is just a preview of what you are doing, and this one is when you are working. Now whatever you are doing here is just to make sure your PC does not hang. But whatever you are seeing in this last one, most of the time is what you render out. So when you have set your materials, if you want to preview your materials, preview it by clicking on this third one or fourth one. But after you have previewed it, when you are satisfied, if you want to do more edits to your model, go back to this first one so that the PC will not hang. Yeah, so that your computer will not hang. So the more detailed, the more advanced we go, the more all these techniques I just mentioned, the render, the texture, I'll keep laying up with much more complex approach, much more complex approach. So this is just like something you can start with and just be fast with it so that I won't bore you with a lot of theories. So I'll still do another video detailing the render, more advanced texture, and more advanced lighting. Yeah, I'll still do an advanced um video on that while explaining the UV and the light. So for now, just keep creating and don't let anything hinder your creativity. Just keep building. See you in the next video.